Hey guys. Welcome to our channel Civil Engineering Guru. Hope you all are fine. As you all know that we are discussing branches of civil engineering. Today our topic is environmental engineering. Branch of civil engineering. So move toward our topic. What is environmental engineering? Environmental engineering is the application of science and engineering principles to manage and improve the environment. As such, topics discussed in relation to the environment normally include water, air and land resources. Sustainable development aims at providing healthy water, air and land for human habitation, for other organisms to survive, and to remediate polluted sites as well. Human interaction with the environment could give rise to an impact on the environment and sometimes is being adversely impacted by pollutants in the environment. A large amount of data will have to be interpreted in the light of the need for sustainable development. As such, environmental engineers will have to be conscious of and find viable ways to cope with such a situation. Now we discuss next topic. The environment. Simply stated, the environment is one's surroundings. To the environmental engineer, the word environment may take on a wide definition and requires a global perception. It should not be a narrow definition dealing only with liquid, gaseous or solid materials within a treatment plant reactor, but it should go beyond that. Global environment comprises the atmosphere, hydrosphere and lithosphere in which life-sustaining resources of the Earth are contained. The atmosphere, a mixture of gases extending outward from the surface of the Earth, evolved from the elements of the Earth that were gasified during its formation and metamorphosis. The hydrosphere consists of oceans, lakes, streams and shallow groundwater bodies that interflow with surface water. The lithosphere is the soil mantle that wraps the core of the Earth. The biosphere, a thin shell that encapsulates the Earth, is made of the atmosphere and lithosphere adjacent to the surface of the Earth, together with the hydrosphere. It is within the biosphere that the life forms of Earth, including humans, live. Life-sustaining materials in gaseous, liquid, and solid forms are cycled through the biosphere, providing sustenance to all living organisms. Now we discuss about the population. So move toward our topic. Growing population puts pressure on both the economic and environmental systems. It brings along a need for more food, fuel, water, and goods and services. As such, it is vital to discuss on the interaction of the aspects of demographic and environment. Population growth means more demand for good lifestyle. Above all, it creates a requirement for more investment to be committed to meet all these needs. Consequently, there bounds to be a rise in economic activities, a direct impact on a lot more people, and an increasing burden on the ecosystem. However, this should not be a case for an argument to be made against population growth. If the environmental, economic and social carrying capacities of the system can cope with the demands, then it will be well and good. It must be emphasized that the purpose of an economy is to provide sufficient supplies of goods and services for the people and not to create more problems. However, there is one vital caveat. For the system to be sustainable, it must have the capacity to generate enough wealth to provide for the necessary investments for the maintenance of the environment and the material requirements of the population as well. In moving towards an era in which environmental stability is a prime factor in economic and social survival, similar observations with the earlier transition from the agricultural age to that of the industrial one can be inferred. That transition became possible only when agricultural production was sufficient to support not only those living on the agricultural land, but also the new industrial population. Now we move toward next topic, that is wastewater and water pollution control. The disposal of human wastes has always posed a serious problem. With the development of urban areas, it has become necessary, from the aspects of public health and aesthetic considerations, to provide drainage or sewer systems to transport such wastes away from these areas. The normal repository was usually the nearest watercourse. It soon became apparent that rivers and other receiving bodies of water have a limited ability to handle waste materials without creating nuisance. This led to the development of purification or treatment facilities where chemists, biologists, and engineers have played important roles. Water quality managers are concerned with the controlling of pollution arising from human activities to ensure that water produced is suitable for its intended uses. Water quality management is crucial in handling water supply to the community. It is very important to know what level of waste is intolerable for a particular water body. To know how much waste can be tolerated by a water body, water quality managers must understand the type of pollutants discharged and the manner in which they affect water quality. Originally, the intent of water quality management was to protect the intended uses of a water body while using water as an economic means of waste disposal within the constraints of its assimilative capacity. Water is a natural resource and plays a significant role in human civilization. Now move toward next topic. Industrial and hazardous wastes. Nowadays, environmental engineers have to face a very tough challenge in dealing with environmental issues. A part of that, they have to develop effective technologies to meet the demand of sustainable treatment techniques. The great variety of wastes produced from the industries and the introduction of wastes from new processes demand the knowledge of chemistry on the part of environmental engineers to find solutions to most of these problems. The problems associated with managing hazardous wastes are particularly complex. Over 100 million tons of hazardous wastes are generated each year in the United States. The U.S. Environmental Protection Agency has placed well over 1,200 sites that are contaminated with hazardous chemicals on the National Priority or Superfund list because of their potential threat to human health and the environment. Now move toward next topic. Air pollution and global environmental change. Pollution of the atmosphere increases in almost direct ratio to the population density and is largely related to the products of combustion from plants, incinerators, and automobiles, including gases, fumes, and smokes arising from industrial processes. The intensity of most air pollution problems is usually related to the amount of particulate matter emitted into the atmosphere. In general, visible particulate matter can be controlled by enforcing relevant regulations. However, the present regulations should be standardized to international standards as they lack certain aspects to meet the demand of current solutions to this environmental problem. These regulations must be updated if they are to be more relevant to the present environmental conditions. The most serious situation develops when local conditions favor atmospheric inversions and the products of combustion and of industrial processing that are contained within a confined air mass. In cases where atmospheric inversions occur over metropolitan areas under cloudless skies, haze commonly called smog is produced in the atmosphere. Under such conditions the atmosphere is often highly irritating to the eyes and to the respiratory tract and is far too intense to be accounted for by the materials emitted to the atmosphere from the varying and separate sources. Research on this field has been extensive. Many theories are postulated with regard to this problem, but the consensus is that it is the photochemical action between oxides of nitrogen and unsaturated hydrocarbons from automobile exhaust gases, combined with several products of health concern, such as ozone, formaldehyde, and organic compounds of nitrogen, that give rise to the condition. These substances can condense on particulate matter in the atmosphere to form fog. Knowledge of chemistry helps very much in finding the root cause of this matter. Now move toward next topic. Introduction to environmental policy. The Environmental Quality Act 1974 with its latest amendment 2005 contains the guidelines related to environmental issues. It comprises legal matters on air, water, land and their impact on the environment. Aspect and impact factors are very important and play a vital role in protecting our environment. It must be realized that human activities will somehow impinge on the surroundings. Activities in factories, for instance, are directly associated with the pollution of the environment. Factories producing paints discharge a lot of toxic substances and they will have to be dealt with properly to avoid the resultant negative impact to surroundings. Understanding of aspect and impact factors is a must for environmental engineers to meet the demand of sustainable development. As a result, we need clear guidelines to be closely followed in order to make sure our activities do not breach the existing laws and regulations. The Environmental Quality Act 1974 allows the Ministry of Natural Resources and Environment, after consultation with the Environmental Quality Council, to define objectionable noise and to prescribe standards for tolerable noise. However, regulations with numerical limits of permissible noise are currently not available. If you guys find our today's video informative, then please like, comment and share our video. If you guys have any questions, you can ask in comment box. Subscribe our channel. Civil Engineering Guru. Thank you. Bye.